welcome back. We are just going to do a quick recap of the stream that we recorded about an hour ago. So we first let's do a recap of a recap. So this is where we had left off last week. So just gonna set up. So this percentage matplotlib. This is a little bit of magic, and here let me just quickly. Okay. So this is what we had last week. We had done these histograms of how often genes appear in samples, so limited to the human gut samples in the GMGCV1, so the global gene microbial gene catalog version 1. And so we discussed that the rare genes that actually the most of them, because this long tail distribution, but the rare genes don't have a lot of information. If a gene appears in 17 samples, it's probably not even going to co-occur with many other genes. So on the other hand, a gene that appears in all the samples, that's also not very informative for our purposes at least. So we will be focusing in the middle ground, and I'm going to take RGI because RGI, this comes from the CARS group, or the same group that builds the CARD database. We respect their work quite a lot, so let's start with that. And then based on that, I'm going to do the same little bit of magic here. I should set this up so that I don't have to do it every time, but okay, I did the same bit of magic here, where we load, and actually, and here, this actually, on the stream, the code had a bug that I actually found the first time I was recording the recap, because the recap didn't look good. I'm just gonna start this because it's gonna take a few minutes to run, or not a few minutes, but it's gonna take a little bit to run. So I'm just running it. All right. So we load the data as before. We count the frequency of the gene. So this is as before. And now here the difference is we are going to take the number of samples, and then we are going to select only genes that appear between 20. So here we just divide by 5 and the maximum. And we do it this way, dividing by 5 with the integer division, so that the results are integers. So yeah, so we have about 6,700 samples, and then we want things that appear between 1,400 and 5,000 samples. And then we look for this. So this line took us a while to run, because I don't know pandas, although I think I still got it quite quickly, to a large extent because I know SQL, and a lot of this feels very SQL-like, and but it still took us a while. But then so then we end up with 325 genes, and then this is this code where we are going to be counting how often these genes appear in the same sample. So the diagonal is going to be the number of genes, so the number of times that gene appears, and then the off diagonal, so the ij, that will be the number of times that gene I appears with gene j. And so the way we compute this is there's this here we select columns I and column j, or the column with the number I, or with the name given in interesting I and in interesting j, and then here we convert these to booleans, and then we sum them, so if we sum booleans, then trues are interpreted as ones, falses as zeros, And so since we have two columns, there's three possibilities. So the sum can be 0, meaning that neither column is true. Can be 1, meaning one of the columns is true and the other one is false. Or, which is what we're interested in, if it sums to 2, then this is both of them are true. So we can see that mask. See that here in this case, yeah. So you can see that this is basically columns of 1, 0, or 2s. And then we set these counts to both. All right. Then here we also spent a bit of time figuring this out to end with this plot, which was the outcome of today's streaming session, where we have here a heat map. So each of these cells is so this means here this is gene at position 252, and this and gene at position, say 91. There will be some sort of number there. That's a count, and that's how often these two genes appear together in the same sample. And as you can see, we have some groupings here. So we use these hierarchical clustering methods to order the columns in some meaningful way, so that the groupings are maximally apparent. If we actually, I can just show it quickly here because we looked at it in stream. So if we look directly at the counts, we don't see them. We see these much smaller groupings. We can ask why we still see some groupings, and the reason is that the names are, and I'm going to steal this term from the chat, they're sorted in alphabetical order, because the uppercase letters and then the lowercase letters, but you can see that there's these groupings. For example, all of the TET genes show up together, and so they are going to constitute one of these mini clusters, but this is still a little bit meaningless. And here we can see that, we have, once we order them by using the data itself, we can see that there's these clear groupings, and that probably some of these correspond to this, all of the TET genes, but there's maybe something a little bit more interesting there, and that's what we will look at next week. So I will actually be also posting on the mailing list. I found this error in the code that we developed during the session, namely that we did not do the sample filtering correctly, and this also illustrates one thing we discussed, which is next week I'll start by cleaning up the code because here I started by taking the previous code and just adding kind of randomly to it, and next week we will start by extracting some interesting parts of the code that can be reused. So not particularly interesting actually, but the code, for example, to load the data matrices, etc. So that will be, they will be extracted out. Okay, so with that, I hope to see you next week, and if in the meanwhile any questions, etc., feel free to email on Discord, or I will see you here.